So yesterday with the algebraic proofs, we went a little further. We went ahead and had them like in the table format where we had the left column and the right column, and we did all the steps. We're going to take it a little slower with geometric because y'all aren't as familiar with your geometric rules and postulates and definitions. But for these notes, what we're going to do is we're just going to have the given statement written here, and we're just going to see, can you do one step after that? What conclusion can you draw from that one piece of information? Okay, so we're not actually proving anything with these. We're just practicing going from one step to the next. What comes next? Okay, because when you're doing proofs in geometry, you got to squeeze as much information from those givens as possible. Okay, so this that's written is like the very first part of a proof. It's the given piece of information, and we're just filling in the next line. Okay, that's all we're practicing. So for the first one, it says the measure of angle 1 equals the measure of angle 2. Remember that little m means measure. So if the measure of angle 1 is equal to the measure of angle 2, what does that mean about angle 1 and 2 and whatever the graphic would be? There's no picture here, but what does that tell me? If the measures are equal, what does that mean? Somebody said it. I don't know who. Congruent. Okay, that is the definition of congruence. If they have equal measure, then we can write that they are congruent. And when you're writing a congruence, you don't have to write the little m, the measure. Okay, you write the measure when you're saying equal. You just write the angle names when you're saying congruent. So if the measure of angle 1 is equal to the measure of angle 2, then angle 1 is congruent to angle 2. Now, my reason that I would put in my reason column over here would simply be the definition of congruent or congruent angles. I'm just going to say congruent. Because when we're talking about the definition of congruence, equal measures, we could be talking about angles, we could be talking about segments. You could use it in more than one capacity. All right, this next one says the measure of angle 1 plus the measure of angle 5 is 90 degrees. Who remembers what that means if the angles add up to 90? Does anybody remember the term or vocabulary for that? It was one of our angle relationships we learned back in Unit 1. Close. Yes, complementary. Okay, so if they add to 90, they are complementary. So I'm going to use the definition. I'm going to start abbreviating definition, just DEF period. That means definition of complementary. That's going to allow me to, I'm just going to have a statement here that says angle 1 and angle 5 are complementary. And I'm going to abbreviate complementary because I don't think I could fit it there. Okay. I now, because they add to 90, I now know that they're complementary. And it could go backward. If you're told these are complementary, then you could write that the measures add to 90. Okay, so all of these could go in both directions. You could start with one to get the other, or start with this one and write the one above it. All right, what about if the two measures of angles add to 180? What's that? Supplementary or supplementary, however you prefer to say it. Okay, so we're going to use the definition of supplementary. To just say that angle 1 and angle 4 are supplementary. And I'm going to abbreviate supplementary as well. So comp is complementary, sup is supplementary in my abbreviations. Oh, hang on. There's a typo there and it didn't get fixed on my screen. Yours doesn't say then. Hang on, let me just put an image over this real fast. Let me get my little camera guy here. Why isn't it moving now? Doesn't want to do anything. Here we go. Select. Man, it's just very laggy. Hang on, guys. Yes. Seriously? Can you please just move where I want you to move? So try again. Seriously? It's like, it's copying it over, but now it won't let me move it. And it's just super laggy. It's doing that. Okay, I may just go to a new page and put it on there instead of covering. And now it's not letting me go to a new page. All right, guys, I'm going to close this out and reopen it, see if it makes a difference. Hang on. Something's just wrong with the app. Technical difficulty. Now let's see if it'll let me put this. Yes, yeah, that's what it's supposed to do. Let me move it. Big though. Okay. That's better. Well, we filled in 1 and 3. Everybody got 1 and 3, right? Okay. Mine had to get erased to make this work. Sorry about that. All right. Number 4 says if this is how we read it. Remember, it has the segment bar above it. So we read it as segment MN is congruent to segment OP, and segment OP is congruent to segment QR. So if we know both of those things, do y'all see how OP is used in both of those congruent statements? So it says that OP is congruent to MN and OP is congruent to QR. So remember in the algebraic proofs yesterday, we said if A is equal to B and B is equal to C, then what must also be true? No? Let me just, you don't have to write this part down. This is a reminder from yesterday. We said if A is equal to B and B is equal to C, what else must be true? Say it louder. A must be equal to C, right? Because B is equal to A and B is equal to C. So A and C must be equal to each other. Don't remember that? That was one of the properties we talked about. That was called the transitive property. That's the same thing that's happening here with line segments. If line segment OP is the same as same length as MN and the same length as QR, then MN and QR must be the same length as each other. So that's what we can conclude from this one. If it helps you, and the property was called the transitive property. If it helps you to have a picture, you could have line segment MN, line segment OP, and line segment QR. And what they originally told you was that MN is the same as OP. So you could put tick marks on those. Those are congruent. And then they told you OP is congruent to QR. Well, I already have one tick mark on OP, so I can put one tick mark on QR. And so now MN and QR both have one tick mark, don't they? So they're the same as well. That's what we're getting at with the transitive property. All right, number 5 says if PQ, segment PQ is congruent to segment RS, what can I get from that? Now, if I don't have any other information besides these two segments are congruent, I really can't get much, but I could reverse it and know that it's still true. I could put RS is congruent to PQ. And that's also one that we talked about yesterday. We said if A is equal to B, then B is equal to A, right? It doesn't matter the order that you write the sides of your equation. Same thing goes with congruent statement. It doesn't matter which order you write your congruent statement in, they're still congruent, right? So that one was called the reflexive property. Okay, now this last one here with this section says if point B is the midpoint of segment AC, I just wrote the wrong property. I just caught myself, guys. That wasn't reflexive. Reflexive just means things are equal to themselves. When you're switching the order, that's symmetric, not reflexive. That's my bad. You have a pencil, just erase. If you don't, just mark that out. Sorry, I just realized that I wrote, oops, that I wrote that wrong. Okay, so you've got symmetric property. It's like looking in a mirror, symmetry, okay? One side is going to be the same as the other, so it doesn't matter which side it's drawn on or written on. All right, point B is the midpoint of AC. This one might help if you have a picture. So if I have a segment AC and they tell me B is the midpoint, where does the midpoint fall? In the middle, right? That's what midpoint is. So what do we know about this picture that I just drew now? Could I tell you anything about these smaller segments that it created? What about the distance from A to B versus B to C? What do we know? If B is the midpoint, is it just anywhere in between A or C? Or is it in the exact center? The exact center. It's in the middle. So that means that the distance from A to B is going to be the same as B to C, doesn't it? So that's what I can conclude from this. I can say, okay, if B is the midpoint, then I know AB is congruent to BC. And the reason I'm able to write that congruent statement is simply the definition of midpoint. That's what midpoint tells us. All right, last one on this side. We've got two segments. They give it to us in the proper congruent statement form where it says segment YS is congruent to segment HM. This is like the reverse of number one. In number one, it was with an angle, and dang it, it erased. But it started out with just that it was talking about the measure and it had an equal sign. And then we wrote that the angles then must be congruent, right? Now they're starting with the congruent statement and we're going to go backward and just write them as equal. Okay, so you can go from a proper congruent statement to an equal measures statement. Notice how it's an equal sign and there's no segment bar above them. This is referring to simply the measure, the length. So that is, again, the definition of congruent. If something is congruent, that means it's equal measure or equal length, equal size. All right, if you flip over to the back, this is talking about the segment addition postulate. Remember, we said a postulate is something that doesn't need to be proved, okay? It does not require proof, but it's assumed or presumed to be true, okay? So the segment addition postulate is worded very confusingly. I'm not even going to bother reading that to you because I think that might confuse you, okay? What it means is that if you have a segment here, AC, if you have a point somewhere, anywhere in between, not the midpoint, it doesn't have to be the exact middle, it could be anywhere in between, you have now created two smaller segments, right? Do y'all see that? We broke it up into two pieces, and those two pieces together would have to add to that total length. So that would be written as segment AB plus segment BC must equal segment AC. That's all segment addition is telling us. It's saying if you have smaller segments that when you put them together, they equal the longer segment, okay? If a point is in between the endpoints of a segment, this will always be true. Okay, so we'll try those examples beneath this when you come back from lunch. The bell's gonna ring here in a sec. I am recording, so I'm gonna keep talking, but y'all have a good lunch. All right, so in this example, we're gonna sketch the picture. It says G is between S and B. So S and B are the endpoints. And G is somewhere in between them. It doesn't matter where you drew it. You could draw it in the exact center. You could draw it closer to S, closer to B. It doesn't matter. Okay, but we want to just write the segment addition equation, just like this one here, for this segment. So that I can color code it again for you. So it creates two smaller segments. Those are my two small segments that together will add to the whole. So I would write SG plus GB equals SB. And that's it. That's all they wanted there. So if you have this scenario, and your segment pieces are labeled with variables or expressions like this, or even just numbers, you can plug in and solve for what's missing. I'm just finishing a video. I'm on the last problem.
Not even schizophrenia.
All right, so this, again, if I color code it the same, what did I do? Green, red, blue. Okay, this would be my red portion. That is GH. So be my green portion, that's FG. And the whole thing is FH. Now they want us to write an equation plugging in what each of those are. And I guess I could have drawn my blue down here since they already had that drawn. It's probably better. So then as an equation, this would be FG is simply X. GH is 2X minus 2. And FH is 4X minus 6. Now this can be solved. This is what we were doing with the algebraic proofs yesterday, was practicing solving equations. It doesn't ask us in this particular example to, so I'm not going to, but you need to be able to solve that for X. Because then you could find the length of each of these segments and the whole length as well. I just wanted to refresh on angle addition postulate. It's the same concept. We talked about this in unit 1. You have this whole big angle ABC. Okay, so that's the big angle ABC. Okay, and then if it has a ray or a line or a segment coming through it, it creates two smaller angles. Those two smaller angles would have to add together to equal the big angle. So ABD would be the one that I did in red, and DBC, the one in green. So that's the same concept with an angle as with a segment. Okay, so that this should look familiar from unit 1. And I just wanted you to see the connection, because angle addition postulate or segment addition postulate, those could be reasons when you're filling out your proofs for a geometric proof.